Let's begin by taking a look at the properties of exponents. Now, I don't want you just to have these memorized for the sake of memorization. I want you to understand them because in this intermediate algebra class, this will be the foundation for the logarithm chapter also. Basically, this is saying when you have two variables or even numbers with the same base here being raised to different powers being multiplied together, you can add those exponents together. In other words, if you have x to the third times x to the fifth, that is equal to x to the eighth. And that is because you have x times x times x times 5 more x's. How many x's do you have multiplied together? 8 of them. When you have division, that turns into subtraction of exponents. So let's say you have x to the seventh divided by x to the fourth. Well, that's like having x times x times x times x times x times x times x. Why did I choose so many? Over x times x times x times x, and you get cancellation of each of these, leaving just 3 of them left in the numerator, having x to the third. So 7 minus 4 is 3, and we can get to the answer a lot more quickly. In this third property, whenever you have a power raised to a power, you can multiply the exponents. Let's say we have x squared getting cubed. That outer third power says x squared gets multiplied by itself 3 times, and using property number 1 up above, you can now add exponents and get x to the sixth. Well, it's a lot easier just going 2 times 3, getting straight to that 6 there. By definition, anything to the 0 power is equal to 1, and I don't want you to get that confused with something like 5x to the 0. Now, if you have 5x parentheses to the 0, that is equal to 1. But this first problem is 5 times x to the 0, so that's really 5 times 1, which is equal to 5. Exponents only apply to what they are directly next to. In this case, the 0 only applies to the x and not the 5, unless there are parentheses saying all of this gets raised to a power. In this final property, negative exponents say, instead of multiply by a or x a times, divide by x a times. Anytime you have a negative exponent like x to the negative seventh, that can become 1 over x to the positive seventh power. Now, I'd like to explain a little bit of how these negative exponents work and why you create these fractions, and I'd like to do that by showing you a pattern here. Let's say we have 2 to the third power. That is equal to 8. 2 times 2 times 2. 2 to the second power is equal to 4, and 2 to the first power is equal to 2. That's all well understood. Now, 2 to the 0 power and 2 to the negative first power is what I'd like to take a look at. Notice that I'm taking these exponents and I'm decreasing by 1, so I've got a pattern on the left, and the pattern on the right is to divide by 2. 2 divided by 2 is 1, and then 1 divided by 2 is 1/2. Notice I've got something to the 0 power equaling 1, and when I have a negative exponent, 2 to the negative first, that's 2 to the positive first downstairs, which is 1/2. So this is consistent with what you already know. Now let's apply these properties of exponents very quickly to simplify each of the following. In problem A, we have the same base, so we can add exponents and have x to the 12th. In problem B, there is no power on that third x, but I can understand it to be 1, so 5 plus 7 plus 1 is 13, and we will have x to the 13th. In problem C, the most common mistake is for people to go 5 times 5 is 25. If those were variables and you had x to the 6th times x to the 11th, you'd have no problem writing x to the 17th. Well, we're going to do the same thing here, just 5 to the 17th. Don't go 5 times 5. Those exponents are telling you how many times the 5 is getting multiplied, and so we have 5 being multiplied by itself 17 times. In problem D, we will subtract exponents to get x to the 5th, And we start to get a little bit more complicated in problem E. Basically, we want to think of this as three separate problems, one with x, one with y, one with z, and in each case subtract. We will have 6 minus 3, so x to the third, y to the 11 minus 7, which is 4, and z to the second power after we subtract 14 minus 12, and there you have it. In this next problem, problem F, you have all of this to the 0 power, so by definition its value is 1. And in part G, notice that the 0 only applies to x, so you have 3 times 1 equaling 3, whereas in problem H, all of it is to a power of 0, giving you 1. In problem I, we have a negative exponent, which says bring me down to the denominator with a positive exponent, and we have a placeholder of 1 up above. There's x squared down in the denominator already, with the x to the fourth that joins it, and so now we have 1 over x to the positive sixth. We never write negative exponents in a final answer because that is not considered to be simplified. By definition, you must always have positive exponents in your solution unless the directions specifically say it's okay to have negative exponents. In problem J, I've got some x's which are going to come up to the numerator and some y's that will go down to the denominator. So up in the numerator, I had 3 x's with 2 more joining it, so there will be x to the fifth. And for the y's, the 4 that are up in the numerator come down to the denominator, and we have 8 plus 4, which will be 12 down in the denominator. And I've already made a comment here just above about these negative exponents. Do not leave them in your final answers.